Hello everyone, welcome to Math 115 College Algebra. This lecture is on section 1.6, which is basically just a review of how to deal with rational expressions, how to simplify them, how to multiply and divide them, and how to add and subtract them. Okay, so basically when you simplify a rational expression, it's the same as simplifying a fraction, because a rational expression is simply a polynomial divided by a polynomial, right? So let me write that out here. So rational expression is equal to a polynomial divided by a polynomial. So basically it's a fraction, right? So how do we simplify fractions? Well, basically we factor the numerator, factor the denominator, and take out factors of 1, right? Anything that's a factor of 1 can be removed. So for instance, let's say I want to simplify this fraction here of 60 over 450, right? 60 divided by 450. So what I could do is I could factor the numerator. Actually, let's just do that using a tree. So I'll find the prime factorization of 60. It's going to be 2 times 30. And then I can branch off the 30, 2 times 15, and then 3 times 5. And then the 450 is going to be what? I guess 2 will go in, right? It's an even number. Goes in 225. And then 2 doesn't work, but I work my way up. 3, yeah, 3 will actually go in, let's see, 75 times, I believe. Yeah, 75. And then 3 will go into 75, 25 times. And then 5 will go into 25 5 times, right? Then it can stop. So basically, 60 over 450, I can write as 2 times 2 times 3 times 5 divided by 2 times 3 times 3 times 5 times 5. And remember, there's always a 1 here too. If you cancel everything, you can't just say there's nothing left. There's always a 1 here, but we typically don't write the 1 unless we need to at the end. So in this case, there's a factor of 2 I can cancel. There's a factor of 3 I can cancel. And there's a factor of 5 I can cancel. Basically what I did was I canceled, if you do 2 times 3 times 5, right, that's 30. So that 30 ends up being the greatest common factor of 60 and 45. So basically I canceled out the greatest common factor of the numerator and the denominator. Okay, and then what am I left with? Well, I still have a 2 in the numerator, and the denominator I have a 15, right, 3 times 5. So that simplifies to 2/15. Okay, it's the same process for rational expressions, except you have to factor out the polynomials. And we spent time in section 1.5 reviewing how to factor polynomials. All right, so let's look at the next example here. Okay, so I want to simplify this rational expression. So I'm going to try and factor the numerator and denominator, right? See if there's anything I can cancel. So if you look at the numerator, first of all, it looks like there's a common factor, right? The greatest common factor that we can pull out of each term, and that would be 3x. And then I'll be left with x minus 2. And then for the denominator, it looks like I can pull out an x, right, is common to each term. And again, I'm left with x minus 2. So the original rational expression now becomes, I'll write it again as 3 in factored form, 3x over x minus 2 divided by x over x minus 2. And notice here we can cancel factors of 1, right? So basically the x's will cancel, and the x minus 2's will cancel. And I'm left with, in this case, 3. So the original rational expression simplifies to 3. Now, you have to be a little careful. It simplifies to 3 as long as x is not equal to 0 and 2, right? Because if you look at the original expression, right, if you factor the bottom, if x is 0 or if x is 2 here, it's going to make the denominator 0. And remember, you can't divide by 0. So really, this simplifies to 3, but we still have to eliminate the possibility that x could be 0 or 2. As long as x is not 0 or 2, then that rational expression simplifies to 3. Because the original rational expression really can't be, x can't be 0, x can't be 2, right? Because you can't divide by 0. We often don't even mention this, but it's an important point, right? It's 3 as long as x is not 0 or 2. Okay, next one. So let's factor the numerator. It looks like the greatest thing I can pull out is a 4. Right, it's common to both terms. I'm left with x minus 3. And then for the denominator, let's see, I want x squared plus 3x minus 18. Remember, we can use the BC rule. So because I have a 1 as the coefficient of my x squared term, I want to find two things, and multiplied give me negative 18, and when added give me positive 3. So I guess positive 6 and negative 3 will work, right? So I know this is going to factor into x plus 6, x minus 3. So the original expression is going to be 4 times x minus 3 over x plus 6 times x minus 3. And then we can cancel out the x minus 3's, right? So this is equal to 4 over x plus 6. That's what it simplifies to. And again, really, x cannot be 3 or negative 6, right? Because you can't divide by 0. Okay, so really we should add where x is not equal to negative 6 and x is not equal to positive 3, right? Because if I plugged in negative 6 into the if you just do it into the original rational expression, it's going to make the denominator 0, or in positive 3 will also make the denominator 0, and we can't divide by 0. So we have to exclude those x values from our domain in this case. All right, let's go to the next page. Let's try this one. So to simplify the numerator, it looks like actually I can factor out a 2, it's common. To every term, so I'm going to have x squared minus x minus 6. And then I want two things to multiply, give me negative 6, and add give me negative 1. It looks like that's going to be negative 3 and positive 2. So this factors into x minus 3, x plus 2. Right? And you could FOIL it back out to make sure that you get the original expression. And then for the denominator, since it's 4 terms, let's try factoring by grouping. So I'm going to group the first two. I'm going to put a plus there, right, to remind myself it's plus a negative 4x. And now I want to pull out the largest term, the largest greatest common factor I can from the first group, which is going to be x squared. And I'm left with x minus 3. And I'd like to be left with x minus 3. And actually, I can do that if I factor out a negative 4, right? Then I'm left with x minus 3. Because negative 4 times negative 3 gives me the positive 12. And negative 4 times x is negative 4x. And now notice the x minus 3 is common, so I can pull it out front. And I'm left with x squared minus 4. And remember, this is like a special factorization here that you should, this is one that you definitely should remember. It's a squared minus b squared, right? Remember that factors into a plus b times a minus b. So in this case, the a is like an x and the b is like a 2, right? This is like x squared minus 2 squared. So this factors into, I got to keep the x minus 3. Then this factors into x plus 2 times x minus 2. Okay, so if I put that all together, then the original expression is going to simplify to this, right? It'll be 2 times x plus minus 3 times x plus 2 over x minus 3 x plus 2 x minus 2. So in this case, the x minus 3 will cancel and the x plus 2's will cancel, right? And I'll end up with just 2 over x minus 2. But again, that's true, so that rational expression simplifies to 2 over x minus 2 as long as x is not equal to 3, negative 2, or positive 2. Okay, so that's a reminder on how to simplify rational expressions. What about multiplying? So if you multiply rational expressions, again, it's just like multiplying fractions, right? So if I have, let me do an example here. Let's say I want to multiply 8 25ths times 5 48ths. I'm going to multiply those two fractions together. So one way of doing this is you simply multiply the numerators, multiply the denominators, and then simplify. But sometimes it's easier to simplify first and then multiply numerators and denominators. So I'm going to do it that way because I think it's a little easier. So if you factor 8, if you do the tree, 8, it turns out factors into 2 times 2 times 2. 25 factors into 5 times 5. Then I have 5 is prime, right? So I can just leave 5 in the numerator here. And then 48 would be 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. Right? And this is multiply. I want to multiply these together. So instead of like multiplying numerators and denominators first, let's actually simplify first, because if something is in a numerator in one of the fractions and a denominator in another one, then they can cancel, right? You can still remove factors of 1 here. So I can get rid of the 2's, right? So basically I've canceled 8 divided by 8, and then one of the 5's. Now notice here, it's not like there's nothing left in the numerator, right? You always have a 1 there, so there's a 1 left. And in the denominator, I have 5 times 2 times 3, which is 30, right? So this is going to equal 1 over 30. So now I am multiplying numerators. 1 times 1 is 1, and then 5 times 2 times 3 is 30. So that would be the simplification. It equals 1/30. Okay, and it's the same thing with rational expressions, right? You want to factor them first, cancel whatever you can, and then multiply numerators and multiply denominators. Okay, so let's do that here. So if we factor the upper left expression, we can use the BC rule, right? So I know the x squared I can only get by x times x. Now I want two things to multiply will give me positive 30 and added will give me positive 11. Well, 6 and 5 will work, right? It doesn't matter what order I write these in. And then for the denominator, same thing. I can use the BC rule. I have x times x. And I want two things to multiply that give me positive 6 and added give me positive 5. So 3 and 2. Times, okay, also BC rule, so x times x. Two things and multiply give me positive 12, add give me positive 7, I guess 4 and 3. And then for the denominator, I want two things and multiply give me 16, add give me positive 8, 4 and 4, right? Positive 4, positive 4. Okay, so before we multiply numerators and denominators, let's just cancel whatever we can first. Because whatever's in the numerator would end up in the numerator, whatever's in the denominator would end up in the denominator, right? So we can cancel these things. So it looks like in this case, let's see, x plus 4 times x plus 4, that's gone. And then an x plus 3, right? Times x plus 3. So then this is going to simplify into, I have, what's remaining? I have x plus 6 times x plus 5 divided by, and then in the denominator, and then times 1, right? If you want to say there's a 1 here since we canceled everything. And in the denominator, I have x plus 2 times x plus 4. So I'll just leave it in factored form. So that would be my answer, right? You could expand it back out, and that would also be correct. But usually we just leave it in factored form. Okay. What about dividing rational expressions? Well, again, this is going to be similar to dividing fractions, right? So let's review how to divide. Let me do a quick example on dividing fractions. Let's say I have 8/15 divided by 2/3. Okay, so what we do is we write the division as a multiplication, right? So remember how this works. The first fraction will stay the same. So that still is 8/15. And then instead of dividing, I multiply. But what do I multiply by? I multiply by the reciprocal of the second fraction. So in this case, I'm going to multiply by 3/2, right? So 8/15 divided by 2/3 is equivalent to 8/15 times 3/2. I rewrite it as a multiplication. And now I'm going to factor all the numbers. I'll just find the prime factorization. So 8 is 2 times 2 times 2. 15 is 3 times 5. And then 3/2 I can't really do anything with, right? So I'll just leave it as 3/2. Cancel whatever I can. So 3's cancel, 2's cancel. And I'm left with 2 times 2 times 1, which is 4. And then 5, remember there's a 1 here, right? And then 5 times 1 is 5. So 8/15 divided by 2/3 ultimately is equal to 4/5, okay? And with rational expressions, when you divide them, you're doing exactly the same thing, right? They're really just fractions, but they contain polynomials instead of just pure numbers. Okay, so let's look at example 5 here. So first, let me rewrite it as a multiplication, right? So the first rational expression will stay the same. Instead of dividing, I'm going to multiply, and I'm going to invert the second one, right? And multiply by the reciprocal. So 2x squared plus x divided by 2x squared plus 5x plus 2. Okay, so now let's factor everything. So the upper left, that's just the BC rule, right? I want two things to multiply will give me positive 6, and added give me positive 5. Well, that's going to be 3 and 2. For the denominator, I just want to factor out the greatest common factor, which is an x. So I'm left with x plus 8, right? X times x plus 8. For the numerator of the second term, I want to take out the greatest common factor, which is just an x again. So 2x plus 1. And then for the denominator, it's a little harder, right? That's going to be like the AC rule. Let me do that on the side over here. So because I don't have a 1, right, in front of my x squared as the coefficient of the x squared term. So I'm going to multiply a times c. That's going to be 4. Two things to multiply give me 4 and add give me 5. Well, that's easy. 4 and 1, right? Positive 4, positive 1. So I can rewrite that middle term, the 5x, in terms of these factors, 4x plus 2. I group, take whatever I can out of the first, so I can pull out a 2x, and I'm left with x plus 2. And then I want to be left with an x plus 2, and actually I already have one. So what am I factoring out? Well, essentially, and it's already there, just not written, you factor out a 1, right? Which means you really didn't do anything, right? You factor out a 1, you're left with x plus 2. So now that x plus 2 is common to both terms, I can pull it out front, and I'm left with 2x plus 1. Right, so this denominator factored into x plus 2 times 2x plus 1. Okay, so now we cancel whatever we can. So let's see, an x plus 2 is gone, and then a 2x plus 1, and then I guess an x, right? And then this is going to simplify into x plus 3 over x plus 8. Okay, so that would be the when you divide those two rational expressions, that would be the answer, x plus 3 over x plus 8. Where again, you'd have to have restrictions, but we normally don't mention all the restrictions for the x's. X can't be certain values, right? Because you can't divide by 0. But given, if you restrict it so you can't have those values, then that would be the simplification. Okay, let's do another one here, and then we'll talk a little bit about adding and subtracting. Okay, so this one, the way to think about this is the second rational expression. You can think of this polynomial as being over 1, right? So I can rewrite this as a multiplication. I keep the first rational expression, it stays the same. And I multiply by 1 over x squared minus 9x plus 20. Right? I multiply by the reciprocal. So factor whatever we can. I guess I can take out a 3. And I'm left with 5 minus x. Can't really do anything with the denominator, right? Just leave it. It's already factored into x plus 6. And then the 1 stays. And then in the denominator, I'm going to can use the BC rule. So x, if it works, x. I want two things to multiply, give me positive 20, and add to give me negative 9. So I guess a negative 4 and negative 5, right? Well, multiply to give me a positive 20, and they'll add to give me a negative 9. Negative 4. Okay, so here, it might look like there's nothing we can cancel, but we actually kind of can. So note this. I'll make a note on the side here. Note that the 5 minus x, if I factor out a negative 1 from there, this is going to be negative 5, right? Because negative 1 times negative 5 will give me positive 5. And negative 1 times positive x will give me negative x. So, and I can change the order of this. I can write this as negative 1 times x minus 5. So this 5 minus x is the same as negative 1 times x minus 5, right? In general, you could say that a minus b is the same as negative b minus a, right? So it switches the terms in the subtraction, but you have to have a negative sign that comes out, right? Negative 1 that comes out. So a lot of times what people do, if they see, 5 minus x, x minus 5, they'll cancel them and then put a negative 1. Remind you that it's really negative 1, right? Because remember this, if I wrote this as negative 1 times x minus 5, then I can cancel x minus 5s, but I'm still left with that negative 1 there. Okay, so you can cancel them, but don't forget you have a negative 1 really. And then if we multiply numerators now, I have 3 times negative 1 times 1, which is negative 3. And then in the denominator, I'm going to have x plus 6 times x minus 4. And that would be the answer in this case. All right. So hopefully that came back to you guys. All right, let's review how to add and subtract rational expressions, which again, it's just like adding and subtracting fractions, okay? So what's the key thing with adding and subtracting fractions? You have to have the same denominator, right? You need to have a common denominator, and usually we find what's called the lowest common denominator. Okay, which we reviewed in section 1.5, how to find the lowest common denominator. So let me do an example first, just with fractions. Let's say I want to add 5/12 plus 3/15. Okay, in order to do this, I can only add them if I have the same denominator. So I need to rewrite both fractions so that they have the same denominator. So how do I find the lowest common denominator? Well, remember we just did this in 1.5. Let's find the prime factorization of 12. So this is 2 times 6, 2 times 3. And the prime factorization of 15, which is 3 times 5. So 12 I can write as 2 squared times 3 to the 1, and I'll put a 5 in there, 5 to the 0, right? Remember, if you want to just make it symmetrical, include all the factors, you can include 1 as long as you put it to the 0 power, right? Because it's just like you're multiplying by 1. And then here I can match them all if I put 2 to the 1 times 3, 2 to the 0, right? Because there's no 2 there, times 3 to the 1 times 5 to the 1. And then I want to take each factor the greatest number of times it occurs in each factorization, right? Because I want to find the lowest common denominator, which is really, so the LCD, which is really the LCM of the denominators. Remember, to find the LCM, we have to take each factor the greatest number of times it occurs in each of the factorizations. So I would take the 2 twice, right? Because the exponent of 2 beats the 0 here, right? So I need to take the 2 twice. 2 squared, I'll just write it as 2 times 2. I need to take the 3 once, right? Because there's a tie. It's 3 to the 1, 3 to the 1. So the greatest is still 3 to the 1. And then the 5 once, right? Because the 1 beats the 0 here for the 5. So this will be times 3 times 5. And if you work that out, I guess that's 60. Okay, so now I can rewrite these fractions, right? 5/12. I want to multiply by something, so I end up with a 60 in the denominator. So what do I need to multiply 12 by to get 60? Well, I need a 5. Actually, you can figure it out from here too. Right? Here's the 12, 2 times 2 times 3. What am I missing? I'm missing the 5 to get me 60. Usually you can just do it in your head though. But because we're not changing the fraction, we're just rewriting it, this has to be a factor of 1, right? If you multiply something by 1, you don't necessarily change it. So I need to put, whatever I put in the denominator, I need to put in the numerator, right? So I need a 5 over 5. And then if I multiply the numerators, I'm going to get 25. So 5/12 is the same as 25/60. I do the same thing for 3/15. What am I missing? Again, you can find it from here, right? 3 times 5, that gives me 15. I'm missing 2 times 2, which is 4. So I need to multiply this by 4 over 4, right? Because it has to be a factor of 1, and that's going to be 12/60ths. And now that I have the same denominator, I can add them, right? Remember, the rule is you keep the denominator and you add the numerator. So 25 plus 12 would be what? 37. And then simplify if possible. In this case, we can't simplify that any further. So that would be the answer. So the original 5/12 plus 3/15 is equal to 37/60. That would be the answer. Okay, so it works exactly the same with the rational expressions. You have to find the lowest common denominator first, and then you can add them, right? You basically add the numerators or subtract, depending on whether we're adding or subtracting, and you keep that same lowest common denominator. All right, so for example, let's do this one. So let's first factor the denominator. So this factors into x. I want two things to multiply, give me +1, add, give me -2. So that's going to be -1 times -1, right? Is +1, -1 plus -1 is -2. This is, by the way, also one of those special trinomials, but I never remember it, so I just use the BC rule. And then x minus 1, I can't really do anything else with, right? It's just x minus 1. So actually, if you think about this, right, we have x, so I want the LCD now. Well, again, it's going to be the lowest common multiple of the denominators. So I need to take each factor, the greatest number of times it occurs in each of the factorizations. Well, the x minus 1 occurs twice in this factorization, once here, so I need to take it twice, right? And that's the only thing. There's no other factors. So the LCD is going to be x minus 1 times x minus 1. Which, by the way, you could write as x minus 1 squared if you wanted to, but I'll just leave it as x minus 1 times x minus 1. Okay, so the first rational expression is all set, right? It has that correct denominator already, right? Remember that x squared minus 2x plus 1 factors into x minus 1 times x minus 1. I don't have to do anything else, so that's all set. The second one, you have to ask yourself, what am I missing to end up with an x minus 1 times x minus 1? Well, I'm missing an x minus 1, right? If I multiply x minus 1 times x minus 1, that'll give me what I want. But whatever I put in the denominator, I want a factor of 1, so I need to also include it in the numerator. So then this is going to be 3 times x minus 1. And then usually you expand out the numerator, right? Because we want to combine like terms. So this will be 3x minus 3 over x minus 1 times x minus 1. Okay, now that I have the same denominator, I can add the two expressions, right? So I'm going to go back up here. I have 5 over x minus 1 times x minus 1 plus 3x minus 3 over x minus 1 times x minus 1. I know my answer has to have the same denominator. And then I add the numerators, which is basically combining like terms. So there's no other x's, right? So I just have 3x. And then what's 5 plus -3? That's going to be a positive 2. Okay, and then that's the answer. And again, if you wanted to, you could write this as 3x plus 2 over x minus 1 squared. Right, that would also be correct. Okay, subtraction is the same thing, right? You have to find the lowest common denominator, but then you subtract the numerators, right? Keeping the denominator, you subtract the numerator. So let's do one example with subtraction. So the denominator I can't really do anything else with, right? X minus 2, that's as far as I can go. The second one, I could factor out a 2, and I'm left with x minus 2. Okay, so if I want the lowest common denominator, well, it's the lowest common multiple of the denominators. I have 2's, I have x minus 2. If you want to write a 2 in this factorization, you can write it as 2 to the 0, right? So I take each factor the greatest number of times it occurs in either of the factorizations. Here it occurs 0 times, here it occurs once, so the greatest number of times is once. I need to take it once. And then I need to take the x minus 2 the greatest number of times. Here it occurs once, right? How do we know that? Because it's to the 1 power. And here it occurs once. So it's a tie, so I take it once, right? Once is the greatest number of times. So my lowest common denominator is just 2 times x minus 2. Okay, so I need to rewrite the first rational expression so that it has a denominator of 2 times x minus 2. So what am I missing? Well, I'm missing a 2, right? And then whatever I put in the bottom, I have to put in the numerator as well, right? It has to be a factor of 1. And then immediately I'm going to distribute in that 2. So I have 2 times 3x, which is 6x, plus 2 times 4, which is 8. Okay, what about the second one? The second one's all set, right? Remember this, so for the second one, I have x minus 3 over 2x minus 4. But remember, the 2x minus 4 is what we want, right? It's 2 times x minus 2. It already has the lowest common denominator in this denominator. Okay, so now I can subtract these, right? So I'll finish it up here. I have 6x plus 8 over 2 times x minus 2 minus, and in here you have to be careful. What I would do is put parentheses, so minus parentheses x minus 3 over 2 times x minus 2. All right, so I keep the denominator, so I have 2 times x minus 2. And then in the numerator, this is really going to be, so 6x plus 8. When I subtract x minus 3, I'm changing both of the signs, right? And the way I like to think about it is I'm distributing in a negative 1. Or you can think about you're adding, but you're changing both of the signs, right? So it's really going to be negative x plus 3. And then if I combine like terms in the numerator, 6x minus x is 5x. 8 plus 3 is 11. And then I keep the same denominator again. So that would be my answer. That's going to be, if you subtract these two rational expressions, you're going to get 5x plus 11 over 2 times x minus 2. Okay, so it is a little bit of work. Actually, multiplication division of rational expressions is a lot easier actually than addition and subtraction. And it's because you have to find that lowest common denominator in order to do the addition and subtraction. Okay, what about, let me just do one more example. This sometimes comes up as well. What if you have what's called a complex rational expression? Basically, that just means you have, in the numerator, you have like rational expressions, and in the denominator, you have rational expressions. So it's a larger, it's like a rational expression divided by a rational expression, right? So there's several ways that you could simplify these. One possibility is, because we just learned how to do this, right? You could add the two terms in the numerator. So you need the lowest common denominator, which is s, right? So you'd have to rewrite the 4 as like 4s over s and then add them. You could subtract the terms in the denominator, and then you could simplify by dividing those two rational expressions. But what I find even easier is you could find the lowest common denominator of all the denominators. So if you look here, since this is just a 4, right, you can think of it as over 1 and a 1 over 1. But I also have an s and s squared. So I have like 1, I have s, I have 1, I have s squared. what's the lowest common denominator of all of those? Well, it's going to be s squared, right? Because I need to take each factor the greatest number of times it occurs in either of the factorizations. So in the first one, there's no s. So if you wanted to, you can ignore the 1, right? The s you could write as s to the 0 if you want. This is s to the 1. This one has an s to the 0. This has s squared. So I only have to worry about the s's. There's no other factors. It occurs 0 times here, once here, 0 times here, twice here. So what's the greatest? Twice, right? So the LCD is going to be twice. And then what you would do is you would multiply the numerator of that complex rational expression and the denominator by that lowest common denominator. So in other words, I'm going to multiply the entire numerator by s squared. So I'll write it this way. If you want, you can put it over 1. And then I'm going to multiply the entire denominator by s squared. Okay. Why does that work? Because really, what's s squared divided by s squared? It's equal to 1, right? I'm not changing this. I'm just rewriting it because I'm multiplying it by a factor of 1. Okay, but you're going to see how this really cleans everything up. So if I distribute this in, right, I'm going to get 4s squared. And then here I have 32. One of the s's will cancel, but I still have another s, right? So it's 32 times s over, in denominator, this is going to be s squared times 1, which is s squared. And then if I multiply times negative 64 over s squared, the s squares will cancel, but I still have a negative 64. Okay. Now let's try to simplify whatever we can. Well, it looks like I can factor out a 4s from the numerator. And I'm left with s plus, 8? And then in the denominator, again, you should recognize this is a difference of squares, right? This is like a squared minus b squared. So s squared minus 64 is the same as s squared minus 8 squared. So it's going to factor into s plus 8 over s minus 8. S plus 8's cancel. And then for my final answer, I'm going to get 4s over s minus 8. So that would be the simplification of that original complex expression. So this whole expression can be simplified into 4s over s minus 8. Okay, so we didn't spend too much time with that, but that you may get a few questions with simplifying complex rational expressions in MyOpenMath. So I wanted to go over at least one of those. Okay, that's great. So hopefully that was mostly review, and that should get you through the 1.6 section of the homework. Great, thank you.